Hi, now is the fifth sum, the applications mixed with many other general knowledge, whipped up together, and you get a lovely pie, a pie in the sky. Just does not come like that. All right, so let's reach the peak of polygons. Now they have 7 cylinders of equal size enclosed in a regular hexagonal open-ended container. You can see the 6 sides, 1, 2, 3, 4, 5, 6, of height 10 cm. The height of the container is 10 cm. Given that the radius of each cylinder is 4 cm and its height is also 10 cm, calculate the following by referring to the cross-section diagram below. This is the diagram. Angle XOY. Angle XOY, this angle here. They want angle OXY, which is this angle. The length of RU, the length of XO. They want to find the cross-section area of the hexagonal container, and they want to find the area of the space inside the hexagonal container. Now we know 6-sided. We did a few sums relating to that. It's really a popular question. They want to find X or Y. What is it again? I told you, my dear friends. If I join here, 1, 2, 3, 4, 5. Remember, each of these angles, they are equal. What is it? 360 divided by 5. So angle XOY is 360 divided by 5, and you got the beautiful 72 degrees. Okay? Or you can say that it's a radius. You can find the side here. Okay? You can find divided by 2. You understand? Okay? Like I did earlier on. You remember there's 6 sides, 6 interior angles. 6 exterior angles is 360. 1 exterior angle you divide by 6, it's a 60. So the interior angle is going to be 180 minus 60. You get, this is not 5 sides. Lucky I did the other method to check. Because 1, 2, 3, 4, 5, 6. What am I doing? Hey, divided by 6, not 5. There are 6 angles. Kumar, yeah. Wake up! Alright, so be extra cautious in looking. So there are 6 triangles sharing 360. Divide by 6, you get a 60 degree. Or your exterior angle is 60 degrees. Alright, for a hexagon, the interior angle is 120. Divide this by 2 because you're dividing it equally because each of these triangles are equal. So this will be 60. These sides are both equal, 60, 60. This will also be 60. It's an equilateral triangle. All right, alternative method. How about OXY? OXY is also 60 degrees, as I've shown you. Why? Because these 2 triangles are congruent. All right, they're all congruent of this regular polygon. Okay, they're both, all this is radius, so they become equal in length. Look at that. Okay, they're congruent. And you can see 120 divided by 2, you get 60. Next, the length of RU. RU. The radius is how much? 4. The radius of cylinder is 4. And this is 60 degrees. So I'm going to take this out and I'm going to show you RU. This is 4. The radius is 4, 90 degrees. A radius is perpendicular to a tangent because they're touching the sides. Alright? They're touching. So I should have included a very important thing. They're just touching here. You see it touching? Touching? They're just touching at these ends here. Alright? Take note. But the diagram itself tells you quite explicitly that this is a tangent. Now, so this is 4. And this is 60 degrees. 60 degrees. RU. And that's your X. So RU will be 4. Alright, the length of RU. Okay? And I think actually you got the length of RU is 4. They're just very easy, direct answer. Now from here, they want the length of XO. Look at XO. Alright, this is 4 radius. They're just testing you. Now they want XO. you need to get the length of XR. This is no problem, it's 4. So this is 4 because it's radius. But what is XR? We need to find out. So let's look at this again. Okay, radius perpendicular to tangent. Now to find the length of XO, XO is made of 4 plus 4 plus XR. XR. Let's look at this again. How do you get XR? Sine XR, sine 60 degrees is 4 over XR. So your XR is going to be 4 divided by sine 60. Please help me there. 4 divided by sine 60, and you've got your answer, which is 4.61. 4 divided by sine 60. So your XR is 4.618. So I get 6188, I put 619. Okay, they get 619. Alright, now if I were to round that up, I get 4.62, 3SF, 4.62 if I round up cm. Okay, now so if we look at XO, XO is going to be XO 4 plus 4, alright, plus this answer 4.62, 3SF, you get 12.62 cm. That's your XO. Now the next part of it, they said find the cross-section area. The cross-sectional area. Alright, now I also want to get back to you here. You see your XR, if you remember that you have if you have a right angle triangle, you want to find 60 degrees. Alright, I just want to tell you this is 2, 2, just an additional knowledge. This is 1 and 1 if it's an equilateral triangle. By Pythagoras theorem, this will be root 3, and this will be 60 degrees, and this is 30. So your sine 60 is root 3 over 2. You can see your sine 60 is root 3 over 2. So you can also work that out using here. You can also. Alright? Okay. So sine 60 degrees is 4 over XR. You worked out your XR, 4 divided by sine 60. Added up together, that's your XO. Now you have to find the cross-sectional area of the hexagonal container. This is your cross-sectional area, this whole thing. Now you got this length, you got this length. The cross-sectional area will be made of how many triangles? 1, 2, 3, 4, 5, 6. So the cross-sectional area, E, let me write that. The cross-sectional area of the cross-section of the hexagonal container will be made up of the area of 6 triangles. And the 6 triangles, 6, half AB sine C. Alright? And you use this formula. And you know, you can cancel this 2, you get 3. Your A and B, this is going to be your length. Your XO, your XOY, they're both equal in length. And what is your XO? Your XO is this length. So it is 12.62. And your B is also 12.62. Yeah. And your sine C is this angle here. This angle here. What is this angle? 60 degrees. XOY, 60 degrees. Sine 60 degrees. So just fit it in. Alright, I'm afraid I'm going to write neater so you can see it. Sine 60 degrees. So you get 3, alright, 3 times 12.62, alright, that's a square effect, times sine 60 degrees. Put that in and you get the area, which is 413.78. 413.78, which is 413.78 7, 8, round up, 3 significant figures, 414 cm squared if they ask you 3SF. So that will be the cross-sectional area. Now my dear friends, the next thing is the space inside the container. What will be the space inside the container? Well, you got to get the cross-sectional area and you got to minus the 6 circles. That will give us the space here, the space here, the space here, all these spaces. And it's not going to be, if you're going to work out in funny other ways, please don't try it. You can nearly die. Alright? Just work it out in a very easy way. All these little space. So you take the cross section minus the 6 circles will give us all that gap here, all these gaps. And you take that gap, multiply it by the height. Remember, this is a prism, area of the space times the height, volume. What they want is that volume of the space. Oh, area of the space, fine. Then you just that space. Okay? So if they ask you volume, let's do area first. The area of space will be the area of the hexagon. Alright? Minus the area of 6, minus the area of 6 circles. Area of 6 circles. So what's the hexagon that you got? 413.78 minus pi r squared. 6 times of pi, and your r is 4 squared. Alright, the area of the space. So let's look at that and work that out. 413.78 minus 6 times pi. Well, I gotta wear my glasses to see where pi is. Pi, where are you? Alright, shift, and that's the button, times r squared, which is a 16, 4 squared, yep. And you get the space area to be 112.18719. Put it together, you get 112. Alright, cm squared. That's the area of the space. Alright, the cross-sectional space. But you want to talk about the volume of the space. That volume will be, you take, alright, I just write down, just this for your inside information, volume of space. The space, because this is the cross-sectional space. But the volume of space will be the area times the height, which is 112 times 10 will give us 1120 cm cubed. Or if you put 112, if you look at it, you multiply that by 10, you just move that up. You get 1121.9, that rounds up to this. 1120 cm cubed. But this is for the cross-sectional space. Alright, the cross-sectional space will be the area of the hexagon. Hexagonal, okay, or is hexagon. Minus the area of 6 circles. And that would give you that space. Are you more confident? Let's look at it again. The sum looks woo, but actually when you get to do it, it's pretty easy because all you need to know is the angles of the polygon property and applying them intelligently, looking at it, congruent similar triangles are all playing a part, and you know that these circles have a radius of 4, and you look at it 4, 4, you need to find out what is this. But if you know this angle, it's 120 interior angle, that's 60. Wow, that makes it a lot more easier. You can see this is the radius, which is 4. A radius is perpendicular to tangent. Alright, this is a tangent. So now you look at this XR, we made it bigger, we could look at this and we could work out XR using sine. Sine 60 degrees is 4 over XR. And bring XR here, you've got your XR. And the length of XO, alright, this whole length is very crucial. This is a radius 4, 4 plus your XR. It's just adding them up. 4 plus 4 plus 4 point. Alright, 62. Alright, remember this is the radius, this is 4 from here to here. There's another little bit here. Look at that, that's why it's more than 4. If you get short of 4, Your answer is wrong. All right, the radius itself is 4. So this is beyond the radius, it's 4.62. So add them all up and you've got the length of XO. All right, and once you've got that, you want to find the cross section. The hexagon, very easy. It's made of 6 triangles. Area of 6 triangles, they are all equal. Half AB sine C. Beautiful formula, base times height. Or you could even, another way is you could work this out. You can find what is this whole thing. You want to work this out, is you got XY. If you want to work it out, it's going to be not very easy. You're going to drop this height and then you can work that out. All right, if you want to. But I would suggest, I don't think you should explore more. The best thing to find the area of the hexagon. All right, area hexagon. Look at 6 triangles staring in your face. Area of 6 triangles. All right, work that out. And half AB sine C, a very powerful formula for the area of a triangle. Once you've got that, okay, and then you want to find the space, area of the space, okay, not the volume of the space, you want the area of the space that's in between the gaps. So you get the hexagon minus the 6 circles will give you the space. But you want to talk about the space inside, the volume of the space, it will be 1120. I would suggest that I should actually say when we talk about space, if it's just a flat 2-dimension, it should be area. But if it is a 3-dimension, look at it, this should be changed to volume of space. That's better because space is to do with volume. So I would suggest that you change this. This is the volume of space. The area of the cross section times the height. That will give you the answer here. So please take note. It will be better that way. Because space, if it's too flat, it's okay. But it's sticking up. So that could be a misinterpretation. Just change that to volume. Alright, my dear friends. The purpose and the outcome of this lesson, this revision, is on polygons and its application. I hope you've mastered it. And hang on. Let's do more revisions. There's also on congruent and similar triangles. And there will also be on volume. Alright, once you master all this, whip it up with your Sec 4, your syllabus, alright, your grade 10 or whatever grade you're studying in, you would find that you would know a lot. Work hard, study hard, cheers, see you, bye-bye.